Hi everyone and welcome. So today we're going to be introducing one of the probably very interesting version of, or at least a different aspect of our Euclidean geometry here, which is known as geometric constructions here. And unlike other constructions, your hard hats are not required here, but they may help if you like hard hats and everything. So basically the idea behind this is you can think of this as just sort of like drawing. This is geometric drawing with two major tools here. The first of our tools, which I think you're all familiar with, is this, our compass here. Note the compass is used to draw circles or portions thereof. So, with circles here, with compasses, in case you don't know how to use this here, you should put this in your dominant hand, put it between your thumb and forefinger on your dominant hand here. You'll note that there are 2 points here. You have the needle part and the pencil part. Don't get the two confused, please. So when you're trying to do something like this here, first things first, I would always suggest is that if you're trying to do constructions here, always have something underneath your paper, whether it's a notebook or a stack of papers or something to sort of add a little bit of friction here so that the pencil can penetrate, so that the needle can go through the paper and hook into the surface underneath it here. If you do this on a surface that's too hard, the paper's liable to slip, okay? So one thing you want to do here is you want to make it so that your needle pierces the paper ever so slightly, and then you can just rotate this here between your thumb and forefinger. So it's like this here, and you just rotate around. And you can sketch yourself, or construct yourself, a very nice looking circle here. Alternately, if you're not very dexterous with your fingers here, you can always just simply use, instead of doing that, you can always just rotate the paper here. You can just sort of move this like this and just have it rotate around, okay? Like that. And you can see that we have ourselves our arc here. Notice that this is useful for drawing circles here. Now, one important thing about this is that in general, this collapses when you don't use it, but it's been proven later on, it was proven that you can actually do much of the same constructions with a collapsible compass as it is with a standard compass that can actually remember things. So this here is actually a compass with a memory function. It allows you to sort of keep one thing sort of stored in the memory of the compass here, and you can use it later on. We're actually going to use this here because it makes things a lot easier for us, okay? So the first thing we have is our compass like this. The second thing that we have here is our straight edge. Now the straight edge here, as the name implies, draw straight lines. So if you've got 2 points like this here, so here's A and here's B, you can use the straight edge to construct a line between the 2 points. Like so, okay? And you can also use the straight edge to extend lines infinitely or however far you want them to go and things like that here. So you have two major tools here, your compass like this and your straight edge like this. Now with the straight edge, it doesn't have to be anything with a measuring device here. So I'm using a protractor here because it came with my set. You don't need to use this here. Anything with a hard plastic edge will do. I find that Metro cards are very good here, or any sort of the plastic cards. Like for instance, I have this, as you can see, this Dunkin' Donuts reward card. This has had a nice rigid edge here, so you can use this to draw lines. And this fits very well in the palm of your hand. So things like this here. Metro cards, all ID cards, these are actually excellent straight edges here. Now, the one important thing about geometric construction, and please make sure that you keep this in mind here. So I'm just going to jot this down so that everybody can see this here. So there are several rules about these geometric constructions. The first thing here is no measurement. So you can't, if you have something, for instance, that if you want to measure something that's 3 inches, there's no such thing. You'll note on many of your compasses, there's a little scale here. Ignore it. Not only is the scale not that good, in geometric constructions, you can't use it anyway. So one of the biggest handicaps that you have here is that you don't have any sort of measurement at all. The only measurements you have are the ones that are given to you. Similarly, your straight edge should also have no measures involved with it as well. I'm having a hard time picking this up. I apologize, ladies and gentlemen. Even though, as you can see, this has measurements involved, ignore them. The idealized straight edge, just draw straight lines, and that's it. So there's no measuring on your compass, no measuring on your straight edge. Another thing to mention here is that there's no guessing. No guessing/estimation. All of our constructions need to be exact. That is, we are guaranteed that if we follow the constructions to the letter, theoretically, we should be able to reach our goal. So, for instance, if one of our constructions is to create a right angle, the construction basically it guarantees us that no matter what we do, as long as we follow the instructions, we're always going to get a right angle. Trying to eyeball 90 degrees doesn't make any sense here. It's not allowed. Okay. Furthermore, another thing here, third thing here, not only is there no measurement, no guessing or estimation here, is that so this ties back into no guessing estimation, all constructions, are exact. Exact in that they will yield you if you follow the procedure. So it's basically as a recipe. If you follow the procedure, you will get to the goal without fail, and that's going to be really, really important to this here. So, with these in mind, it's very difficult to conceive. Wait a minute, if you only have this and you only have this here, just what can you do with just these two things? And when you're hampered by these handicaps here. As it turns out, with this and a little bit of geometric knowledge, which we already looked at over the past several months here, you can actually do quite a lot with this. And what I'm going to be doing here over the next 6 or 7 sessions is I'm going to be guiding you through the theory and why these sorts of things ought to work.